Let's talk about software as a service security tips, especially for non-technical co-founders, especially for MVPs, software products in the early stage. We have a comprehensive slide set here, which I want to go through. If you do these things, it's very likely that you don't run into problems. And I think anyone who's starting any kind of software business should know at least these basics, because you actually don't want to end up on this website here, like the French-German Interrail, where they wanted to sell a lot of tickets but got a lot of problems with their server, went down, and then they had security incidents by this website just uncovering everything. So these basics we can take care of, and it's actually not that hard if you use the proper tools. So let's go into this. My name is Till Carlos, and I was a developer, and now I am a technical product manager. We're building here our venture studio with multiple apps, and I know a bit about software development as well. So I thought I would give an overview about SaaS security. The first thing I want to talk about is who actually has server access. If something happens, who can fix a server? There should be ideally more than one person. So there's so-called bus factor. If the main person responsible for an app is having an accident, is getting rolled over by the bus, what would happen to your software? Can it still survive? Can you transfer the ownership or the management of the app to someone else very fast? How long would it take? That's something to consider. And the next thing is authentication and authorization. This is something that everybody should know, especially if you're a product manager. Usually those things are basics, but maybe you're coming from a background where you have not learned that. So let's go into this real quick. Authentication basically only says to verify who someone is. So when you're logging in with a username and your password, the system will know you are that person. And there are a couple of things you can put in. You can put in multi-factor authentication. This is when you have your phone and you put another security token. You can enforce strong password policies. Those are good ideas, but of course also try not to make them too strong, else people will just write down the password and then the might not even be the best security. So there are a couple of things that are too detailed for this slide here, but in general, the passwords should be stored in the database in an encrypted way, so salted and hashed. Authorization, on the other hand, is giving people permissions to do certain things. So let's say the system has established that someone is a user. Now with authorization, the system gives the user certain rights. And yeah, usually those are put into the code or into the database. Important is that you, as the product manager, you have an overview of those. You either have a table or you made some kind of document that describes those so the developers can adapt to that. Developer might not even do those when they start out. They might just give everybody all the rights. The simplest way is just have an admin access for the people working with the app and then the actual users. This is the basic thing. And there's also the thing called the principle of the least privilege, which is handy to know. Basically, the idea is that you only give people so many rights that they can just do their job. Don't give them more than they need. The next thing is just app security standards that are now very common in frameworks. So that's why we always encourage people to use frameworks. So you can use Ruby on Rails or Phoenix from Elixir or Django, whatever it is, or Laravel in PHP. There are many, many frameworks. It's important that we don't have things like cross-site reference scripting or SQL injection, because those things will usually just give an opportunity for attackers to break into your system. We can look into this post, the top 10 web application security risks. There are a couple of things that go into detail, but you can ask your developer, once you have a developer, ask them if they have implemented this kind of list and what kind of security standards they put into the software. They usually have a good answer to that. If they don't, maybe they tell you they haven't put everything in, but they wanted to. So there's definitely something you can put on the backlog for your features. If you still have time to work through this, you can add a contingency planning, meaning you plan for unexpected events. You can make a table like this. You ask the developer, what's the likelihood of this happening? And then you put some kind of contingency plan for every item there. I think this is a bit much, especially for small software products. But maybe it makes sense. If you're launching a SaaS and you expect high user demand, you expect this thing to be in the media, all these things, yeah, then it might be a good idea to even make a table like this. And then we talk about error tracking, which is super important because if bugs happen, you want to know that before the customers know. Ideally, maybe one customer triggers a problem and then you catch this thing very fast and able to fix it. There's a good overview about logging and activities you can have a look at. But in general, I would say in this case, just ask the developer, what kind of loggings do we have? What kind of information are you capturing? Can we look into this? And ask the developer to give you an extract. Ask them, how can we see that we have an error? If they have a good answer for that, then awesome. If not, they might admit that they need to put something in place, that they need extra time for that. And then I wanted to talk about the general mindset of software and what it means to keep software maintained. In general, software is not an asset, it's a liability. What does that mean? An asset is something that gives you financial gain over time, something that appreciates in value, or it just gives you a return. And a liability is something that results in an outflow of money. So let's say in order for software to stay at the same level of value, you would constantly need to update it and fix it and have a maintenance fee attached to that. So what we mean by this, we need regular updates and a maintenance budget, because we need to update the software. We need to make sure that it's always using the latest packages, and any kind of vulnerabilities are fixed along the way. And just one ballpark figure, let's say you have an app that takes 100,000 to develop. Usually the maintenance, just to keep it as it is, it's around 15 to 20% of that. And I think that's a good measure. And the last thing we want to talk about is backups, which is super important, and many people don't put enough emphasis on that. It's not just that you need to have backups, you also need to make sure that you can access them, that you actually have the possibility to get the backups whenever you need them, and they're not stored on the same server, for example. And all this together would make a good overview of a security for a small software system. In general, I wanted to put this out just to be clear. You can totally over-engineer security, but the biggest problem is still that nobody actually buys the software. Because if that happens, the software is just dead as an insecure one. And I think that's totally correct. And I would always first to make sure that the software actually runs, provides value, and then add those things. Yes, when I launch a software as a service, of course I have backups, because I've done this before. And of course we have all the security standards from Ruby on Rails. But I don't overcomplicate logging. I don't give the access to 3 other people, because if something goes down, I can fix it myself. It really depends on the level of where you stand with your software. How do you like these measures, and do you think anything is missing? Just put a comment below and let me know.